Oh, gotta plug in, don't we? There we go. All right, so did you take that first problem right here and go ahead and be working that out? Okay. Doesn't want you to forget how to do those things. Go ahead and finish up. See if your answer matches the one we get up here. So 2 times 2 is?
4.
Okay. 2 times 8?
16.
16. So your top row is 164. Okay. We know to put that 0 there. If you forget it, draw that dinosaur head. Sometimes we'll leave that off here and there. Just, a lot of you are leaving it off now because you've gotten in that routine. 5. So we're done here. 5 times 2? 10, put the 0, carry the 1. 5 times 8, 40 plus 1 more, 40. 100, and I know that's running into that, but we've got a 4 here, a 6, a 2, and a 4, so 4,264. Okay. And if you didn't, look back and see, did you get 164 here? Did you get 4,100 here? Because that tells you, where did I go wrong, perhaps. Okay. Sometimes it's when you add. So, all right, clear that off, and let's go ahead and grab that second one. 4,284 divided by 6. I will squish this up in here. Okay, give you a second. That out, and if you do get finished, go ahead and check it with multiplication. Always good practice to do that. Check it out. It's a good feeling when you check it and you see that you've gotten it right. We start this problem We've got 6 as our divisor. We're going to ask ourselves, can I get a group of 6 out of 4? Nope. But I can out of 42. How many 6s? What's the most 6s I can get out of 42? 7. 6 times 7 is 42. So put that 7 up there and multiply here. And we're going to subtract that 42 and bring down the 8. What's the most 6s I can get out of 8, Bailey? Right here. Just 1. Okay. So 6 times 1 is 6. I subtract that and get 2. And then bring this down. Caleb, what's the most 6s I can get out of 24? 4. 6 times 4 is 24. So again, this time we have no, what? No remainder. Okay. Let's multiply real quick to get to just check and see. 6 times 6 is 36. 6 times 1 plus 3 more is 9, and 6 times 7 is 42.
You put a 6 where the 4 is supposed to be.
Okay. So let's
Here? No.
Oh, I sure did. I sure did. Okay, but see how something so simple can mess you up completely? Because if I'd have thought that was the answer, I'd have gone and reworked the whole problem. I don't know if you caught what he said that I did. When I wrote the problem, I wrote it wrong. I wrote 716. 714 times 6. So easy to make those types of mistakes, to copy something wrong. 6 times 4, 24. 6 plus 2 more is 8. And then 42. All right. Thanks for keeping me on my toes.
Did you mean to do that?
No, it was just a pure accident. All right, this guy is kind of hard to see, but let's put the factors of 18. Factors and multiples are one of those things that we don't spend forever on, so we tend to forget it. The factors, or it could say the factor pairs of 18. That might help you remember what factors are if we called them factor pairs. Okay, of 18. All right, tell me one of them. Tell me one of them. Yes.
6.
Times what? Huh?
3.
Okay. So 6 times 3. Yeah.
18.
1 and 18. 1 and 18. Yeah. 2 and 9. Anything else you can think of? You kind of start looking at, if you're not sure, are there any more? Look at the numbers that are in between. In between 3 and 6 are 4 and 5. Is 4 times something 18?
No.
4 times 4 is 16. That's about as close as we can get. 5. This number doesn't end with a 0 or a 5, so 5 is not. And once we get right here, we're kind of on the other side. If no other numbers in the middle work, then we should be finished. Okay? So there we go. 1, 2, 3, 6, 9, and 18. Okay, go ahead and clear that off. Now I'm going to ask you to go ahead and put your top on your marker and push all that aside. We are going to watch a little bit before we start in using our markers and all that. for the last couple of days, we have been doing adding and subtracting with fractions, and I have a feeling you feel pretty good about that. How many of you feel like adding and subtracting fractions is pretty easy? I mean, it hasn't been bad. Okay. And I think it is too. But a lot of times when we bring on a skill, you know, we start simple and then we build on it. Now, I'm not saying today is hard. I do think it will stretch your brain just a little bit more when we keep working with addition and subtraction. What you're going to see is some bigger numbers. Well, how do you get bigger with fractions? Because they're little pieces, you know. The whole number that's going to be with them up until now has been 1. We're going to see the whole number start getting larger. And that makes some differences here and there along the way, okay? So we're just going to see how to handle it because it's not hard. It's just a little different, you know, just a few other little things we need to add to what we already know, okay? So we're going to jump here, okay? All right, I do want you to grab your marker at this point. I'm going to ask you to try this before I show it to you. Forgot I was going to do that. All right, so on your board, you might want to turn your board a long ways. I don't guess it matters that much, but turn it more this way. Okay. Is that yours? Okay. Okay, it just came to see you. Okay. All right. Here we have a math problem. You don't have to write this math problem, but what I do want you to write, if you've written it, it's okay, is a tape diagram, long skinny rectangle, to show this. Yep, we're bringing back some of our visuals today. Okay. Namely the tape diagram today to show this. What might it look like? Okay. Now you are purely kind of guessing right now, but you guys know a lot and could make an educated guess. What might a tape diagram look like to go with this? It's got to show 2 wholes plus 1/2. Okay, because you want your tape diagram to be like a picture that shows this happening. Okay. Your tape diagram is just a long, skinny rectangle. Okay. Yeah, not area model. Tape diagram doesn't build on top. It's just a long, skinny rectangle. As it's not the area model that has more than one, you know, stacked on top of it, it's just the long, skinny rectangle. They are different that way. Sometimes we cut a tape diagram, and mainly that's when we're multiplying. Any ideas? And it may be easiest just for you to show your board and us talk about what you've got. Now, you might not feel like I've given you enough information. I do want to say I want you to try and show this on one tape diagram. Can you show on one tape diagram 2 plus 1/2? I'm actually going to erase that and change its color so we can see it a little better. Okay, I don't guess it has to be that long. Now, one thing that helps us with this tape diagram is labeling it, because we can label it however we need to. Alright, so I'm looking around. Nobody's really labeled anything. Okay. How many of you feel right now kind of a little bit lost? You're not sure what to do. Totally okay to raise your hand, because I would be. Okay. Totally fine. All right, so put your hand down. Put the top on your marker for just a second. And I think once you start seeing a few examples, it'll be like, oh, no problem. Okay. So if we want to show 2 plus 1/2 on a tape diagram, we're going to need to show, tell you what, I'm going to do this right quick. All right, so I'm going to need to show first 2 holes. Well, I'm going to do that by this right here. Now, at first, that might look like, oh, Miss Wendy, you're showing 1/2 and 1/2. I'm not, and this is how I'm going to make it different. I'm going to label this as 1. I'm going to label this as 1 hole. Okay, or I could have put 1 big bracket and said 2. You know, I could have done it all together. All right. Now, there is my 2 holes, and I showed that with that label. You see what I mean by labeling it? I could have said this is 1/2 and 1/2 if I had a different math problem, but I need to show 2 whole pieces. So here we go. And now I need to show that I'm adding 1/2. So I'm going to draw a little piece right there, and I'm going to call that 1/2. Okay. And so this is showing 2 plus 1/2. And what would 2 plus 1/2 equal? Yeah. 2 holes and 1/2. 2.5. It's just moving them together. Yeah. It would. It would. Because look here. He says if we'd have changed this to an improper fraction, or if it had been an improper fraction first, it would have been 5/2. If each of these holes was cut in half, how many halves do we have? We have 1, 2, 3, 4, 5. So you can see it on the tape diagram. Okay. Tape diagram, sometimes when we hear that or when we hear number line, we tend to think, I don't know. I want you to become familiar with the tape diagram enough where you just, it's just becoming the picture of what's happening. That's all it is. Okay. All right. So hopefully it's not going to be as hard as it sounds like it is. So let's try this one more time. Okay. Whole different math problem. You can write the math problem on your board. That's fine. But you need room at the top of your tape diagram to be able to label it. Now, anybody not understand what I mean by labeling it? I need to show where is 1 hole, or where is the hole number 3. I've got to label that at the top. So let's create a tape diagram to show this right here. Go ahead. Okay. What would it look like if you were asked to write a tape diagram for this problem? And yours might not be perfect this time, but that's okay. I think you have more information this time. You also might need to leave yourself some room out to the side to add on to it. Don't forget to write what these are. looking around, I'm seeing a lot more labeling going on, of course. Somebody want to describe to me what they did, and we can. What'd you do?
So I drew 30 parts.
3 parts.
Yeah.
All right, I'm gonna go ahead and do that. Something like this.
Yeah, and then I put in each part I put one hole.
Okay.
And I draw 30 parts in each hole.
So you went and created one hole, and you divided them into thirds.
Yeah.
Okay. She divided hers into thirds. Is that okay to do, everybody? Yeah. Did you have to do that? You didn't have to do that. She just did. Okay.
And then I did 10 more blocks, and then I did like the label, and I put 2/3.
Kind of like that. I just changed colors so you could see it better. All right, and then put a 2/3 above it, like that. Okay. Is that one way to do it? Yes. Did it have to be done exactly? You needed a lot of that, maybe not every single part of it. You did not have to cut each one hole into thirds, but you certainly could have, because that made it easier to see. Oh, I've added 2 more that size. I've added 2 more thirds. Okay. But a lot of what I saw was exactly correct. Okay. Anything else that you think we could do to show we're adding this? You know, that this was here first, and then we're adding that part. I'm just asking. Anything else that would make it clear to somebody looking at your picture that, oh, they're adding?
Put plus signs.
You could put plus signs. Could you show it with shading somehow? How could we shade it so that you could tell this was part of it and then this was part of it, you think? Yeah.
Pretty much you would shade all of it.
You would. Could you shade it maybe 2 different colors so you could see what was there first and then maybe the new part? What is under my? Is that your marker?
Yeah.
All right. I'll get your marker.
Silly.
Okay. It's coming to attack me. All right. So, all right. Go ahead and clear this off. You know, adding, not too bad. You're just drawing what you have first. Look at the problem, guys. We're drawing what we had first. We drew 3 whole boxes. We labeled them so we knew this was one hole, this is one hole, this is one hole. And we added a little piece to it to show 2/3. Okay? All right, now, subtraction is different. So I want you to put the top on your marker and lay it down. I want you to see this. Actually, before you see it, could you, without me telling you, think of a way to show subtraction with a tape diagram? Go ahead and try it. Again, you're kind of guessing. You're going off of what you already know. What is something you could draw with a tape diagram to show 3 minus 1/4? What would this look like on a tape diagram? No, it's not 3 and 1/4. It's 3 minus 1/4. Okay. It is okay right now to say, I don't know. I kind of expect that since you haven't heard it yet. Yeah. How are you going to do that? Yeah. Great question. Okay. So put the top on your marker. the top on your marker. Lay it down. Great question or comment. I know I got to take stuff away. I just don't know how to do this on my board. Okay, hold on. You got to show 3 holes somehow, and a lot of you had that part. Okay, and a lot of you had labeled to show this is a hole, this is a hole, this is a hole. You know, I've got 3. It's the taking away part that kind of threw some of it. Okay. All right, what did you do?
So what I did is I drew tape and I cut it into parts.
Okay.
And then each part I cut it into 4 pieces and I put 1 hole above it. And after I done that, I shaded 1 part for that could be like the tape.
To show it was taken away. Okay. So her shading showed that it was taken away. That's how she showed, you know, that it was gone. A lot of times we think of that as that's the piece we have, but maybe we could let our shading be what we don't have anymore. Yeah.
So I drew 2 1 holes, and then on my last hole, I cut it into 2 parts.
You cut it into how many parts?
2. And then I would show 3 holes.
Okay. So you're showing it already gone, like what would be left. So his is demonstrating really more the answer to that than the problem, which is, you know, that makes sense as to what y'all might think, but we're going to go a little differently than that. I guess with what we are going to wind up doing, it's going to be close to what Reagan did. Not exact, but close. Okay? Close to what Jayla did, but not, you know, not exact, but close. All right, so clear your board and just watch for a second. The subtraction one is probably the one people have to think more about. Adding, we just hook on to the end. Subtraction, a little different. Okay, this is what I mean by stretching our brain a little bit today, just causing us to have to stop and think for a minute. All right, so we have 3 holes. Guys, in subtraction, you usually have a big amount you start with, right? Or a bigger amount that you start with. So I'm going to show that. I'm going to cut this into 3 pieces, and my 3 pieces are going to be, yeah, each of them are going to be 1 hole. And I could make one big bracket across the whole thing and just say 3. That would be the quickest way to do it, but this works too. Now, I've got to somehow show that I'm taking away 1/4. Now, is 1/4, hold on, is 1/4 smaller than one hole? Yeah. Yes. Is 1/4 smaller than 1 hole? 1/4, 1 hole? Yeah, of course it is. We know that. So really, I just kind of need to focus on 1 hole. I could cut all of these into 4ths. I'm not. I'm just going to cut one of them into 4ths. Okay. Could all of them be cut into 4ths? Yes. I'm just going to cut one of them right now because I really only need one of them. I need to show. Now she shaded hers. I'm just going to go like this. Okay.
What?
Either way would work. I just took that away. Got rid of it.
That's what I was thinking.
Okay.
I knew you had to.
Now, let me see what I have left. I have 2 holes. So, I need to get that whole number part first. I have 2 holes left. And how much of this do I have left? How much? No. Look at it. It was 4ths. There were 4 fourths in that 1 hole, but what's left?
3/4.
3/4 are left. This is left. This is left. This is left. So I have 2 and 3/4 left. You see how that just happened? Okay. Now, why is she just doing 1 piece? You could have done this. I think it messes up some people when they only have to cut one of them. Cut them in 4ths because our denominator is 4ths. If it helps you to cut them all into 4ths, do it. But you really just need one of them because that's the only one I took away from. Okay? All right, let's try one of these because these we need to see a few more examples of. Let's go right here. Okay? So let's do this one together. So get your marker ready. Here we go. We're going to draw a tape diagram to show this. So we need a piece, a tape diagram that is showing how many holes. What's our hole number, Valerie, that we're working with? 3. So we're going to let this show 3. This used to be 1/3 when we were dealing with smaller numbers, but today we're going to let it be 3 holes. I'm going to put the bigger bracket this time, but in my mind, I know this is 1 hole, this is 1 hole, this is 1 hole. We see that? Are you drawing it? Because I need you to be with me right now. Okay. All right, don't draw on them because you're going to... Okay. What would come next, do you think? What would we need to do next? Yeah. Okay. Let's stop right there. I'm going to grab that little, draw the thirds. Caleb recognized that our denominator is 3, so we're going to be working with thirds. We're taking away thirds, so I need this cut into thirds. You know, I can cut a hole. I could take this piece and I could cut it into 15ths. I could cut it into 6ths. I could cut it into thirds. I could cut it into whatever size piece I need. I can cut these 1 holes into any size piece I need, and this time I am cutting all of them. Do you have to cut all of them? You could just cut the last one.
Oh, it has to be the last one to cut. It's easy now that I know how to do it.
Yeah, it is. Once you see, whoa, yeah. Now that you've set up, listen, now that you've set up your tape diagram, I've got 3 holes. I've cut it the way it needs to be cut. The subtraction's easy. Take away 2 of them. Take away 2 of the thirds. Subtraction done. Now I just need to count up what's left. How many whole pieces do we have left? This one and this one. How many are left? How many whole pieces are left? 2. And then what's the fraction piece that's left? Brandon, what's the fraction piece that's left?
1/3.
Just 1/3. This little guy right here. When you slash through them, if you're kind of careless and you accidentally make it look like an up and down line, and then you start counting too many pieces, be careful. If it's better for you to shade it so you know it's taken away, you mark it the best for you, okay? If you want to put an X through that piece, do that. Make it very clear of what you've done, okay? So now I have this 1/3, so my answer is 2 1/3. And you can see that so, as plain as day, so easily seen on the tape diagram. Okay. Let's try one more. I don't think, I don't have one more for you, but I'm going to go dig one out somewhere. I could make one up. But I just assume. That's weird. Okay, here we go. Well, I'll leave that. Let's go to a place where I have some room. Oh, boy.
Oh, pictures. Oh, yeah, they are.
Oh, I'm glad to read about germs and sick people sneezing every day.
That's the one you have to make small.
Why? Why? Why do you do this to me?
Exposed.
And then there's like 20 behind it.
I thought since this one went here, I went here. I mean, you'll be like this when you do this one. Go to the side. Go to the side, and that's what all the buttons.
We're gonna figure this out before the end of this year.
We need the FBI. We need the FBI to
Okay.
investigate. Then we come in your classroom next year.
We're still gonna be, same thing, still throwing them away. All right, so what if I had up here 7 minus 4/5? I'm going to let you try this one, okay? You're going to start with a tape diagram that shows 7 holes. So draw a tape diagram and cut it into 7 pieces, but label it at the top. You can label it with the number 7, or you can label it each section, you know, one hole, one hole. Okay, we're drawing the tape diagram for this. Now, make it large enough because these are fifths. Be careful because you're taking away. You don't need that extra piece. With subtraction, we don't add on an extra piece. We start with our whole number, at least on this problem. Unless our 7 had a fraction with it, so. Okay, you've got to label it, guys. You've got to label it so I know. Do you know what 1 hole is? Do you know what 7 is? You know, label it at the top so that I know what is what. What are we going to cut these little pieces into? Fifths, because our denominator is 5. Now, if I was subtracting a fraction that was bigger than 1, I might want to cut several of these into fifths. But I know I'm subtracting a fraction that's smaller than 1, so I'm just going to cut one of these into fifths this time. Okay. How many of these fifths are we taking away? How many of these fifths are we taking away, Peg? Look at the math problem. Yeah, 4 fifths. So I'm going to X out 4 of these. Okay. And I love the tape. Once we get, once this becomes easier for you, this is so nice because I look at it, I know my exact answer. How many whole numbers do I have left? Let's count them together. 1, 2, 3, 4, 5, 6. I have 6. That's my whole number. And then how many fifths, Gage, do I have left? These are my fifths. That's what I cut into fifths. How many is left? Just 1. Okay. So all we're doing, draw a tape diagram that shows that first number, because that's your biggest amount. Then cut it with that denominator and take that many away. Okay. All right. I think we might feel better with one more of these. I would feel better with one more of these. So clear off your board. All right, this time we're going to do 3 minus 3/4. All right, so you're going to start off by drawing the first number. Y'all can draw a rectangle and cut it in 3 pieces and label it with a 3 at the top. So is that one hole? The whole thing? Yeah, be careful here. Make sure your label shows what the first number is. That's your first step right there. Okay. What are we going to cut these into? What is our size piece? Yeah.
Fourths.
These are fourths. Okay. These are fourths, and we're taking away how many of them?
3.
3 of them. Okay. Taking away my 3/4. Now, you just got to carefully count up what you have left so you don't miscount. Okay. Brandon, what do we have left?
We have 2 and 1/4.
You're exactly right. And that's easy to see because here's 1, here's 2, and then here's that little bitty fourth. Okay? All right, so try to slow way down on this subtraction. Help us get this. But you guys are doing it great. Okay?
I like this.
Well, I'm glad. Y'all want to do one completely by yourself?
No. I do. Please, please, please.
Let's do that.
Please, yes.
They don't take long.
It takes like 4 seconds. Okay, maybe here.
Okay, there you go. Minute to try and finish this up. Label things because I would think that's fractions, not whole numbers. Okay. What answer did we come up with? What answer did we come up with? Look at your tape diagram. Maybe you already wrote the answer down. What answer did you come up with? Bailey, did you get an answer? Like how many whole numbers do we have left? Okay, 4, and then how many, what fraction do we have left? 1/6. Anybody else get 4 and 1/6? That's what she got. Okay, now I want you to see this. Put the top on your marker, and I need you to hear a couple things. By the end of today, we're going to do some of these problems without the tape diagram. And you may be sitting there going, yeah, I don't have to draw all that. But I'm telling you, it's easier to see these problems with the tape diagram. Okay? When we do this problem, we know this is 5. Okay, you're putting everything down and giving me your eyes up here. We know that our denominator is 6, so we're cutting these into 6 pieces. Okay, and I know I'm getting rid of 5 of them. So just like Bailey said, we've got 1, 2, 3, 4 whole pieces, and then this little fraction, right? Let me ask y'all a question. Y'all look up here for a second. Didn't I say earlier that you could cut every one of these into 6? Right? Okay. So keep that in mind. Keep that in mind. The problem that some people have when they see a math problem like this is they think, I can't do that. I can't take 5/6 away. I don't have any 6 over here. What? Okay, there's not a fraction over there that has 6, but you could have 6 in every one of those whole numbers. You have, look, there's 6 here, there's 6 here, there's 6 here, there's 6 here, there's 6 here. If I have 6 5 times, how many do I have? What's 6 times 5? What's 6 times 5, everybody?
30.
30. Okay. I have 36. That's hard to say. I have 36 in this whole thing. I have 30. It's like the bank. You know, it's like somebody saying, can I have 5? And I don't have any. You don't have any. You're like rich over here with 6. You got 30 of them. Okay? The problem is we don't see them because this is a whole number. We don't see, it doesn't have a fraction over there that says 6. And so that bothers us. Okay? But if we could have a picture like this that showed us, oh yeah, I've got lots of 6. Because I could cut all of these into 6. I've got as many 6 as I need. Okay? We don't always have that picture to see that. And that's what throws us off sometimes. Okay? All right, so let's take a little detour for just a second. And I want you to look at, tell you what, I'm going to keep this up, but let's get a blank screen. All right, if I have this, and I say, okay, I need a number bond here. What pieces can I easily break that into? Let me give you a hint. Okay? It's kind of like a little fact family. Y'all put everything down. Okay? All right, so what if I had okay, break those apart. What could go at the bottom? Yeah. And 1/3. Okay. What if I had, trying to think how best to ask this. Could these 3 numbers, let's do one more. Hold on. If I had this and this, somebody break that down for me. Because number bonds help us see fact families sometimes. Yeah.
Do the 2 in one bubble and 1/5 in the other?
Okay. So 2 and 2 and 1/5 and 1/5 kind of go together there, right? Right? Okay. How could 8 7 and 5/5 go together. Okay. This could be a fact family too, but I need to know where to put what number. What goes where? What goes where, Martin?
The 8 goes on the first line.
Here?
Yeah. With 5/5.
Here? Or 5? Where?
Up there.
With it? Because remember, these two things have to make that. So you're putting them together. So now you've only got one thing left. Okay? Because these three things need to fill these three spots. Okay? So think again. Think again. And I'm going to go ahead and tell you those can't go together. Okay? So do you still want the 8 up there? No. You know, one of those might go in there. They're both not going to go together. Will, help us out.
The 8 goes in the circle.
Okay, everybody's eyes need to be watching this because we're all going to be doing this in a little bit. Okay?
And then the 7 goes on this side, on the left side.
Okay?
And then 5/5 equals 1, so it goes on the
Okay. Get the little dots out of the way here. Okay, that is correct. Go ahead and tell you that. You've just taken 8 holes, like we drew on the tape diagram, and you've broken it into 2 pieces. 7 holes and 5/5. Because isn't 5/5 equal to 1? Any number over itself is equal to 1. Cha, cha, cha. Okay, ready? Here we go.
I knew it.
Here we go. Hop up.
Wait.
Y'all are
Everybody
fading fast.
has to do it.
I told you this was a brain stretcher today, so it's making us think, and y'all are getting too quiet on me. Any number.
Any number.
Oh, whoa, come on. Any number
Any number
over itself
over itself
is equal to 1.
is equal to 1.
Cha, cha, cha.
Cha cha cha. Gage didn't do it. You have to do it
Do
again.
it. Any number.
Any number.
I just need you to repeat. Any number
Any number
over itself
over itself
is equal to 1.
is equal to 1.
Cha, cha, cha.
He's not doing it.
Okay, but take care of yourself right now. Okay, have a seat. All right, we want to keep that in mind because that keeps showing up, and here it is again. Okay, can you picture in your mind this as a tape diagram? This is like the 8 holes right here. We cut this into 8 pieces. Oh goodness, that's too, hold on. All right, if this was cut into 8 pieces, this is exactly what we've been doing on our board. This is important to see. If this was 8, okay, all of this, and then if we had one of them cut into 5/5, you'll see that last one cut into 5/5. So now we have 1, 2, 3, 4, 5, 6, 7, and 5/5. You'll see that? Because when we start working with the numbers, we're going to use a number bond and break down one of our numbers so we have enough fifths, or maybe we need enough thirds, or maybe we need enough eighths to do the subtraction. Okay? So that's why we started off with tape diagrams, so we can kind of understand what's happening. We're taking that whole thing and we're breaking part of it into fraction pieces. Okay? All right. Let's go ahead and go here. If we need to back up in a minute, we will. Okay. Is your board cleared off? If it's not cleared off. Clear off your board. Okay. So here we are with this problem. And you're not going to draw a tape diagram. How do you figure out the answer? Because how do I pull this out of this? Yeah. Now I really want you to think here for a second. Hold on. We're not. Okay. We're not on our board yet. Okay. Let's think for a second. And I'm going to give you a chance to talk with each other for a second. Okay? How can we turn this 5? We know with a fraction, you know, if we don't have like other fractions like it, maybe with the same denominator, it's a little harder to subtract. So what can we do to maybe this guy to make it easier to subtract? Okay, so talk with each other, the people that are close to you, for a second, and think, what do you think you might could do? Share some ideas with each other. You might not know how to do it yet, but what might be something we're going to do? All right, so we're back in 5, 4, 3, 2, 1 1/2, 1 3/4, 1/3, 15 hundredths.
0.
0. Okay. Okay. So what might we do? What's a thought?
So we said draw a number line to like.
Okay, draw a number bond with the 5. Okay, so maybe something about a number bond. Any other thoughts? Yep.
5 is like 4/4, so I put 4/4 5 times and then plus 1/4.
Okay. You added it or you took it away? Which, I mean, I still see what you were doing with the 5. He's still breaking the 5 down into fourths. Guys, this is 5 wholes, so this would be 4/4 5 times. That's a lot of fourths. Okay? All right, so
You said
number bonds, breaking it into the fraction that you see. Y'all got some good ideas here. We're going to take that 5 and we're going to make a number bond. What do you do with the 5? Okay. So we're going to make a number bond. I realized it right after I did it. Okay. Where's my bubble? There we go. We're going to take that 5. Okay, let's not write right now. We're going to do it in just a second. Just watch. We're going to break that into a number bond. Now, Will was correct. We're going to break it into fourths, but I don't want to have that many fourths. Do I need that many fourths? Do I need 20 fourths? I don't right now. So how about I just pull one of those out? One of those. Remember how in our tape diagram I just did the one box at the end, or some of you did it at the beginning and broke that one down into a fraction piece? Here we go. Take 1 away from 5. Okay, so we're left with 4. 4 wholes. But that 1 that we took away, that's what we're going to break into fractions. That's what we're going to break into fourths. Please sit down. Okay, that's our number bond. So now we have 4 and 4/4. Take away 1/4. Well, how does that work? How does that work? The whole number we can leave alone because we have enough. Do we have enough fractions to take that fraction away? Okay, I need y'all to stand up. Stand up. Because I have a lot of y'all just staring off. I know this is a lot. You've got to be with me or you will not get this. This is not easy. Okay? But it's also a lot harder if you're not even looking where I am. You got to plug in. Is it hard work? Yeah. Is it hard work to stay focused? Yes. Okay. All right. Sorry. I'm sorry this is not football. If I dressed in a football uniform and taught this, would that make it better?
Yeah. Yes.
Okay.
Yes.
I'll search for one. All right. 5 jumping jacks. Ready to go.
I forgot how to do it. So
Okay. Stretch up as high as you can. Make
Yeah,
yourself
we'll
tall. We
try
got that. Some of y'all gonna touch the ceiling. All right. Bend over and stretch.
I can't touch my toes without bending my knees.
Okay.
Okay.
All right. Shake your arms out. Shake your legs out one at a time so you're not floating in the air. Okay. All right. Have a seat. Have a
Can we
seat.
do the thing?
Okay. We have 4 and 4/4, and we're taking away 1/4. All right. Get with me. I need your eyes right here. How does that work? That whole number, do we have to touch it anymore? Because do we have enough fourths to take away 1/4? Can I take away 1/4 from 4/4? Yes. Yes. So that 4 just comes on over and becomes part of our answer. You know what a lot of 4th graders will do? They'll forget to move that whole number over. Changes your answer a whole lot. Now 4/4 minus 1/4 is just 3/4. Okay. So that is our final answer. Yeah, I bet y'all liking that tape diagram a little bit better about now, aren't you? At first we were like, nah, tape diagram, but now you might like it a little better. Okay. It does show this very easily. Okay, but we do have to learn how to do this without drawing something every single time. Okay. All right, so let's try this together, and we're gonna walk through a few of these together. So if this is like, what are we doing? It'll get easier the more we do it. So get your marker ready and stay with me. Okay, follow directions, please. That would be a good thing to do right now. All right, here we go. We're going to start with this one. We're not drawing a tape diagram. We're going to instead do a number bond on the number 7. So we're going to circle it. What is going to go below it? How are we going to break 7 apart? You got to know how to do this. Yeah.
You put 5 on the left side and 2/5 on the right side.
No. Not 5. Help us out.
You put 6 on the left side and 2/5.
Okay, remember we're taking one of the pieces of set, one of the whole numbers. So we're just taking one away. Okay, look up here if you're not sure what to write. 1 less than 7 is 6. The other one, what are we going to put? Yeah. What? Because these two pieces have to equal 7. We're not doing anything with this yet. But I have to have 2 things right here that equal 7. Yeah. Well, it's going to equal 1, but I'm not going to put the number 1. Because, Faith, what I'm trying to do is create something, make it easy to subtract this. So think about what form I would put that 1 in. Yeah. 5/5. How did Bailey know to do 5/5? How did she know that? That's all we need to answer right now because some of you are like, no? What?
So if you put the 6 down, then you have like 1 more hole, and then just look at the denominator.
Okay. You said the magic words right here. As this denominator all along has been important for us to look at. It shows us how to cut the number line. It shows us how to cut the tape diagram. It shows us all right, it shows us what to put right here. 6 plus 1 is 7, right? Y'all have known that for a long time. 6 plus 1. And Faith, you were right. It's 1, but it's got to be written this way so that it matches this. This is like somebody that wants to look good. They want to match, want their outfit to be all snazzy. Okay. Got to match the denominators here. All right, so we have 6 and 5/5. Let's rewrite that. 6 and 5/5 minus 3/5. Did that just become easier? Yeah. Now, the only thing that's different than like the last couple of days is we have this whole number sitting here. You got to do some checking first. If I have enough fifths right here to take these away, can I take 3/5 away from 5/5? Do I have enough fifths? Yeah. If I have 5/5, can I give you 3 of them? Yeah, I have enough. So that 6 can just jump right over here. We leave that 6 alone. Hey guys, get with me. Have we written this? Everybody's board has this? Okay. I can only do so much, and you guys got to meet me halfway. Okay. All right, let's take our fraction away. What's 5/5 minus 3/5? 2/5. That's that easy fraction subtraction stuff we've been doing. You've got to remember to move that whole number over, though, or you won't have the right answer. I'm sorry, you can't see that. It's becoming clearer, I think, the more we do it. Okay, let's do another one. Okay, what are we going to do first? Circle the 3. Because that's telling us we're going to do a what? Yep. Yeah. The part you really, I think, is what do I break it down into? All I need is 2 things that equal 3. I need 2 things that equal 3. What are we going to put? We're going to put a 2. And we know it's got to be 1, but it's not going to look like a number 1, is it? It's going to look differently. Okay, so Kennedy's right. We got a 2 here, but what do we need with the 2? Yeah, it's got to equal 1. Any number. We don't always do that just so we're acting silly for a few minutes and have a break out of our seats. Listen to the words. Any number over itself is equal to 1. Cha, cha, cha. Okay, what? 4. Yay, I got it. 4/4. Why 4/4? Because we have fourths here. Any number over itself is equal to 1. Cha, cha, cha. Okay. So this is equal to 1. 1 plus 2 is 3. Okay. I just changed the name of 3. Did you know that 3 can be called 2 and 4/4? You can. How old are you? I am 7 8/8 years old. Yeah. Okay. That's what you want to call it today? You go right ahead. But you can do that. Okay. So now we have 2 and 4/4 minus 1/4. Okay. Get with me. How did I get this? I just took it from right here. Okay. 2 and 4/4 minus 1/4. I need to know what to do here. We all do. We all need to know what to do here, but Mark, what are we going to do?
We're going to take the 2 over there.
Over here? Because I don't really need it, do I, to do any more subtraction?
And then you're going to subtract 1/4 from 4/4, and you'll get 3/4.
Okay. Once I move this over here, I kind of don't, I just ignore it. It's moved. Now 4/4 minus 1/4 is just 3/4. Okay. Y'all are very hard to read.
Now I get it. I get it a lot.
We're either I don't understand it or this is just totally boring. Okay.
Boring.
This is not for everybody. I get it. You don't go home and do this in the afternoons. Hey, you want to come over and work some fraction problems? Yeah, be fun. I get that you don't do that.
Yeah.
Probably.
My mom said I gotta clean my room.
Yeah. Just as bad. Fractions, clean my room. Which one's worse? All right. So, I just need to get a read on y'all. So here we go. This is on your own.
Oh, okay.
Maybe y'all are just sitting there because you know exactly what to do and you're tired of talking.
Yep.
I get it. Tired of me talking too?
No. Probably not.
Mhm.
The only thing I have trouble on here is that I have to put on the side.
Like the number one part? Yeah. Well, you are not the only one. So, I'll tell you what, though, I'm going to draw this just as a hint. This is going to hopefully help somebody. That is an important number right there. Okay, just rest your arm for a second because I think it's going to take a few minutes. Feels like something. Sometimes we do the number bond thing and then it's like, oh, I'm done. No, then you take that and you do the subtraction after that. It was fine if it was 4. You know what I'm saying? You worked it for me.
I pulled my grippy off and done that to my pencil.
A regular.
Yeah. I pulled it off and done that. How did it break? She just like pulled the lead out of it. It's a magic. Which inside of a pencil. We need super glue.
That's why, you know how you will sharpen a pencil sometimes and it keeps breaking, it keeps breaking, it keeps breaking? Because that thing inside is one long piece. And sometimes when it hits the floor all the time, or maybe you tap your pencil a lot, it will sometimes break that inside.
I did this.
And so, you got a pretty hard head, so it might. Anyway. So it might, that lead inside might be broken in several pieces, and so when you go to sharpen it, you think you're good, but then
It's
you
a
can.
different
Y'all
color.
ever pulled it right out right after you sharpen it? You know, it's because it's broken inside sometimes.
It's a different color right here.
I don't know.
Than
Interesting.
this pencil. See?
I don't know if I've ever seen that happen with a. I thought it was is that a mechanical pencil that looks like a?
I don't know.
No, it's not. It's not. But at first,
Elizabeth's treasure box.
at first when you showed me, I was like, maybe that's a. Some of the mechanical pencils look.
Like pencil.
Yeah, they color them to look like that. Okay, so you guys have this problem on the board. A lot of you have worked it out. Alright, tell me how to work it out. Faith, what would I do first? Okay. This becomes 4 and 5/5, which is just another name for 5. This is just another name for 5. So, Alexander, what would I do next? This right here? Okay. So, 4 and 5/5. Yeah, I have to rewrite that math problem. Just the 5 has a new name. And so now when I do the subtracting, what am I going to get? Isabel, what do I do with that 4? I just bring it to the other side, don't I? Because I really don't need it with the subtraction. So I'm going to, if you want to draw that arrow, if that helps you right now, draw the arrow. There's nothing wrong with that. If you don't need that arrow, you don't have to draw it. Okay? What is my last step here? What is my last step here to finish this off? Brandon, what am I going to do?
You're going
I've already taken care of the 4, so I've got these 2 fractions left right here. What am I going to do with them?
you're going to subtract 5/5 with 2/5.
Okay, so I have enough fifths, don't I? I have 5. I'm going to take 2 of them away, and so I have 3/5. So how many of you came up with 4 and 3/5? Now, I did see this happen on several boards, so that makes me feel better. Maybe y'all are just bored this morning and not, you know. Anyway. All right, here's the plan. We're going to do one more just like this, and then we'll move to the problem set. Now, if you're still feeling like, about this, sometimes things like this do take a few days to kind of sink in really good, and a few days of practice. So don't get distressed if. All right, we will change this to 4 minus 1/3. Okay. Go ahead and work this one and see what you come up with. Change the 4's name. All right, I'm seeing some really good things on your boards. Even if I didn't see your final answer, I'm seeing the correct steps getting you there. So, what is 4 going to be renamed as? Yeah, go ahead. You got it. 3 and 3/3. And we know that it has to be thirds because of that denominator right there. Okay? Now, what do I do with that? What do I do with that, Reagan?
You put it together as the next number.
Okay. And what do I do next?
Then you subtract 1/3 from it.
Okay. All right, give me the next step right here. Okay, move that 3 over. And the final step, Faith, what would we do? Yeah, subtract the 1 from the 3. And how many thirds do we have left, everybody?
2/3.
2/3. Yeah, 3 and 2/3. And I did see a lot of you with that. Okay.
I got it.
All right, so like I said, this is a brain stretching day.
Is there a way to check it?
Yeah, to work backwards.
Oh, never mind. Stop right there. Stop right there.
Okay, but watch. If I take this mixed number and I change it to an improper fraction, 3 times 3 is 9, plus 2 more is 11, 11 thirds, and I add 1 more third to 11 thirds, I have 12 thirds. What's 12 thirds?
4 times 3.
12 thirds, look at it. 12 thirds, that's really a division symbol. 12 divided by 3 is 4. Ding, 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 ding. Okay. In other words, if I add back the 1/3, will I get 4? Yeah. Okay. All right. Let's put away our boards and markers. We're going to take our restroom break. Come back to a fresh start into our workbook. I'm not asking you to do every problem in there today. I've only circled a few. Well, I've circled less than what there are. Let's say that. So, all right.